class. Today we're going to be doing section 3.10, so this corresponds to chapter 10 in our AP statistics book. And we're going to be learning about a randomness and simulation, kind of to do a simulation to, simulate an experiment or a real life event that would be otherwise difficult to duplicate. So the essential insight in gathering data for statistical analysis is the central role of randomization. So whenever we gather data or conduct an experiment or a simulation, we want to make sure that we have some sort of randomness. So either people are randomly selected, or people or subjects are randomly assigned to different treatments in an experiment, or if we're doing a simulation that our numbers are randomly generated or something like that. We need to make sure that there's randomness involved. The reason for this is we want to minimize any influence of effects that we can't control. So for example, a National Health Organization wants to determine if a strict low-fat diet is better for a person's cholesterol level. 200 volunteers were allowed to choose either a strict low-fat diet or one that primarily consisted of fast food meals. The cholesterol level of each volunteer was then measured after a year, and it was discovered that the volunteers on the strict low-fat diet had a mean cholesterol level that lower than that of the fast food volunteers. Can we conclude that a strict low-fat diet is better for a person's cholesterol level? Well, unfortunately, not really. So there's a couple things. We have volunteers, which is fine. In our country, we can't really force people to do experiments. So we're always going to be dealing with volunteers. So that's not something we can really change. But the problem with this is that those volunteers were allowed to choose which diet they wanted. And that is a problem. So if they're allowed to choose the diet, people who usually live a healthy lifestyle will probably go for the low-fat, healthy diet as opposed to all of a sudden eating a bunch of fast food. And so the difference in cholesterol levels might not even be caused by the diet choice, but might be caused by other factors of their healthy lifestyle, such as regular exercise or something like that. So in this experiment or study, to make it better, what we would have done is taken the volunteers and then randomly assigned them to either one of the two diets. That way we have a mix of people who live healthy lifestyles and people who might not in each one of the groups. So randomization is really important. So a simulation is going to mimic reality by using random numbers to represent outcomes of real events. So I'm going to be using the TI-84 Plus graphing calculator to run this simulation using a random number generator. Other options, as silly as it might sound, you can actually put numbers in a hat and draw numbers from a hat, but there's a little bit of some details involved in that need to be met, such as making sure all the numbers are on equally sized pieces of paper and that the hat is mixed before each draw and that the person's not looking in the hat. And so a random number generator is nice because we don't have to discuss all those details to make sure that that was done properly. So suppose a basketball player has an 80% free throw success rate. We can use a simulation to determine how many shots in a row that she can make without missing. We call each simulated result a trial. The most basic building block of a simulation is the component. In this example, the component is each shot. So the trial is going to be how many shots she's going to keep taking over and over again until she misses something. And then each shot is the component. So before we actually run the simulation, we are required to do the following steps. And it's a little bit of writing. So first, we have to identify the component being repeated. So in this case, the component is attempting a shot for basketball. The second piece, we have to explain how we're going to model the outcome of the component. So coming back up, we want to know how many shots in a row that she can make without missing. So since a player has an 80% free throw success rate, we can assign digits 0 through 7, so that's 8 digits, as a successful shot, and 8 and 9 as a missed shot because we have a 20% failure rate. Repeat numbers are allowed. So a couple things really quick before we keep moving on. The reason I started with my digits at 0 is because if I use 0 through 9 for my percentages here, then I can use just single digits. If I started and said 1 through 8 and then 9 and 10, because 10 is a 2-digit number, we would then have to create all the numbers to be 2 digits. We can't mix 1-digit and 2-digit numbers in our trials. So if possible, start with 0 so that you can use only single digits. The second piece is you need to state clearly if repeated numbers are acceptable. So what that means is while I run this simulation, if I randomly generate a 5 and then I randomly generate another 5, is that allowed? Well, in this case, it is, because a 5 just represents a successful shot. Examples where it wouldn't be allowed is if numbers represented like individuals, like people. Each number represented a person that you were choosing. Well, you can't choose the same person twice, that sort of thing. So sometimes repeats are allowed, sometimes they're not, and you definitely need to think about it and state it in your statement here. Numbers will be obtained using a random number generator on our calculator. Next, we need to explain how we will combine the components to model a trial and clearly state when to stop each trial. So we're going to simulate consecutive shots for each trial using the random digits generated, and each trial stops when we obtain the first missed shot. And you can be specific if you want to say digits 8 or 9. But we want that context in there, so don't leave the context out. And the last piece here, state the response variable. So what are we recording? What did they ask us to find? They asked us to find how many successful shots she can make in a row before missing. So the response variable is the number of successful shots made for each trial before missing. Now that we have it all set up, and I know that that's a decent amount of writing, we want to run the simulation. So before we use our random number generator, I want you guys to seed your calculator because the calculator is a computer. And if you've never run random numbers in your calculator, they're all going to be exactly the same. Like one person's calculator is going to pop out the same random numbers as the next person's calculator if they both have never run this program. So what you want to do is in your calculators, type in some random number. You could use your phone number or just random digits. Oops. Except not, I shouldn't have hit that. Okay, so just some random number. Now hit the store button, STO with the little arrow, and then go to math, over to probability, and the first one that says random, hit enter. And it's going to do this. It's just going to pop back out the number. But what that means is now from now on, when I run my random number generator, it's not going to be the exact same numbers as everyone else is going to be getting. And you only have to do this once. You never have to do it again. You're welcome. All right, so to run our trials, so we're going to record the random numbers generated in each trial in context. So we go to math, go over to probability, and then I'm going to go down to random integer. So I don't want just any random number, which could have decimals in it. I want a random integer so that I'm just looking at single digits. Now I'm going to hit enter. And I want my lower value to be 0, upper to be 9. I just want one digit at a time. And I'm going to hit paste and enter. So here's my first number. Now, is that a successful or a missed shot is what you want to figure out. So this is a successful shot. Remember, a miss is an 8 or 9. So I'm going to record that, and then I'm going to run another one. And I'm going to have the number 5. That's another successful shot. Another successful shot. And remember, I'm going to keep doing this until she misses. Oh, and there it is. Okay, so 9. So this is a miss. And the other ones were not. So then record your result, your response variable. So remember, what are we recording? We're recording how many successful shots she had before she missed. So 1, 2, 3. So this was 4 successful. Or here, what I'm going to do is I'm going to do this. Successful shots. And then this is 4. So I don't have to write successful shots every single time. All right, so then we do it again. We just keep hitting enter. So my first digit here is a 7. That's a successful shot. Oh, and then 9. So that was our miss. So this one only ended up as a 1 successful shot before she missed. And then, trial 3, she misses right away. So that has 0 successful shots. So this was a miss. Next trial, she is not doing so well. And this is completely random. Remember, there's only a 20% failure rate. And you might be thinking, well, but if it's only 20%, why am I getting these numbers so quickly? And that's what random numbers are. Each number has the same probability of showing up. So, all right, so trial 5, we have a 1 and a 2. So far, so good. A 6, a 4, another 4. Remember, repeated digits were just fine in this simulation. 7. Ooh, she's doing well. Oh, and then our 9. Okay. Missed. So that is going to be 1, 2, 3, 4, 5, 6 successful shots. Now, I know it didn't say how many trials to do. Sometimes the test will say run 6 trials or run 10 trials. If it doesn't, I would say close to 10 trials is good. I don't want this video to be too long, so I'm going to do 6. All right, so 7 and 1, 2 so far. All right, 3, 0 is a success. Another 0. Oh, and a miss. All right, miss. 1, 2, 3, 4, 5, 6 successful shots before she missed. All right, so here's 6 trials. I could keep running more. Maybe around 10 would be really good. Now, we're going to analyze our results. So first, I want to summarize the results of the trial. Sometimes, and now I'm going to find the average of all of these numbers of successful shots based on the context of this problem. An average makes sense. Sometimes an average won't make sense. So you'll need to kind of think about the context and whether or not that makes any sense, or whether you just kind of talk about the results. So summarize the results. So I'm going to do 4 plus 1 plus 0 plus 0 plus 6 plus 6 divided by my 6 trials. And let's grab our calculator. So 4 plus 1 plus 0, 0, 6, and 6 is 17. Divided by 6 is 2.833. And I'm going to write shots before missing. Now, in stats, especially AP stats here, we want to make sure to state our conclusion in a full sentence with context. So based on our simulation, so this isn't like for sure this is always going to happen. It's just based on our simulation. Based on our simulation, the player will make an average of 2.833 shots in a row before her first miss. Now, you can't make 2.8 shots, so you could round. You could say 2 or 3, depending on if you're saying, well, that's 2 made shots. She didn't quite get to 3, or whether you're rounding to the nearest number. As long as I've shown my math and it's clear where that number 2 or 3 is coming from, then you've pretty much covered all your bases. All right, and then the only other thing I wanted to say is that with simulations, now this simulation, I only did 6 trials, and I ended up with this. But if I had kept doing more trials, or if I ran the simulation again, and I did, so repetition in stats in real life, a good experimental design or even a simulation design is going to have a decent amount of trials and a repeated repetition of your simulation or your experiment. Because just because I got these 6 trials this time and these numbers doesn't mean that next time we'll get the same thing. So it's good to keep doing it over and over again in real life so that you can have a real average and not a small sample size. All right, and that's it for today's lesson.